two correct ways to work this problem. And of course, any correct way is perfect with me. I am going to show you the easier of the two ways, but talk you through the other option as well. Okay, so the first thing you have to do is graph and find intersections. As we know, that's no matter what we're doing, that's going to be our first go is find the draw the graph, find the intersections. We are looking for the common interior. So we are looking for this area here. Our formula is not for common interior. Typically, our formula gives us area in between, right? Where we, like this area or even this area. But one option is to do the area in between and find this little area here, right? And then subtract that from the whole cardioid. That's one option, and it is a wonderful option.
And we can do either of the areas, correct? Finding the whole of the right side.
Right. You can find the whole and then subtract. You could do that in a lot of different ways. Works wonderful. I hope you can do that if you must. There is an easier way. I am looking for that common interior. And if I start drawing slices of, remember, the way that we calculate area is by tiny pie-shaped slices. It turns out I could do the area from here to here just by doing slices. Would you agree with that? Well, then I could do the area from here on around with other slices just on a different curve. So, option 2. Now, option 1 is, I think you could probably piece together option 1 is finding the area between 2 and subtracting from the whole. Option 2 is actually doing some addition. So I could find the area from this intersection to this intersection of the cardioid. So first of all, where is this intersection? Okay, pi over 3, this top one's pi over 3, right? You could even go from 0 to pi over 3. Why could I get away with doing that? Symmetry, so I could do 2 times 1/2. So using symmetry, I could just go from 0 to pi over 3. I am only getting that top area there of the cardioid, which is 1 plus cosine of theta squared d theta. Plus, I could do the area of the circled, kind of that blue area there, which is on the circle. And because I'm doing sections, I could get away with that. Again, I'm going to use symmetry in my favor. 2 times 1/2. The integral from pi over 3, question mark. We'll talk about that in a second. Of the circle, 3 cosine theta squared d theta. I know I want to go to here. This was a calculator question, right? Now you may know where here is, but I do want to show you using your calculator because I haven't done this yet, so you probably figured that out already. But F3 is your trace button. Have y'all seen that? And so I could get on the circle curve, which I actually am. If I'm not on the one I want to be on, push the down arrow. It'll move you over to the other curve. And you can move to the right, and it'll show you the angle that you're on. And so I want to go to the x-axis. And it says 1.57. Well, that gives me a good idea of what I'm looking for. You may not know what 1.57 is, but if you go to your home screen, you know it's not pi, right? My guess is pi over 2. Oh, ding, 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 it is. So you can use your calculator to find where it hits the x-axis that way?
Where's that approximation?
Diamond enter. Just diamond enter will do the approximation. So this is pi over 2. The other way to do that by hand, I kind of prefer the calculator option. I don't know about you. If it's going to be a calculator question anyway, make my calculator do the work. The other option is to find when the circle hits the x-axis, which is a y-intercept. And we know that y equals r sine theta, right? And so you could set that equal to 0, and you would get 0 pi over 2 pi, 3 pi over 2, right? Was it Joseph, you came up to my desk, or somebody did and said, 0 to 2 pi goes around this thing twice? Was it you that said that? Sometimes it does. On this one, because of that, because of the nature of that circle, it goes all the way around at pi. So just be careful. Anyway, type that in the calculator. Is it 5 pi over 4? I think I worked it earlier. I think it's 5 pi over 4, but check. Now, is it okay if you did the whole area and then subtracted? Absolutely. We don't care if you get right answers. We don't care where they came from. Except another person's paper, then we care. But any questions about common interior on this one? So, 2 ways you can do common interior often. One of them is the obvious, where we could do the subtraction and then subtract that from the whole area. The other option is just breaking the integral into 2 pieces.
It's so odd. Doing it that way is 3.6.
You got what?
It's 3.96.
I think it's 5 pi over 4. Which calculator gives you the 5 pi over 4 answer? Yes. The TI-89 will actually give you the 5 pi over 4 answer. TI-84 will give you the decimal equivalent of. Yes. Now there's 2 different ways to do it. The way I did it when I did it total area is I found the area of the cardioid. You know, the part. So 1/2 0 to 2 pi. 1 plus cosine theta. So option 2. Okay. Squared d theta. And that is the area of the entire cardioid. Right. Then I found the area of these little guys here. That makes sense. I did only find the area of one of them and then multiplied it by 2. But you could do that either way. So the small green area, that would be the integral of the cardioid. So 2 times 1/2, because I'm just doing the from pi to pi over 3. Nope, from pi over 3 to pi. That makes sense so far. Of 1 plus cosine of theta squared minus the, and you could do this different ways. I did, this might not make sense, But I did the integral from pi over 3 to pi over 2 on the circle, which gives you this whole thing, pi over 3, right there, right? On the circle. 2 times 1/2, right? Does making sense? And it's pi over 2 because, remember, the circle... Okay, you're not lost. 3 cosine theta squared. Say that again. Good question. So back to the calculator for a moment. You know this intersection is pi over 3. Pi over 2 is this place here. Remember we found that by tracing earlier. So going from here to here, just that top half. Now you could have gone all the way from the 3 pi over 2 all the way, or the pi over 3 all the way to the 2 pi over 3, and then you wouldn't have to double. And if I hadn't been splitting, if I hadn't split on the top, I probably wouldn't have split on this one. So you could have gone all the way, and either way.
Is you split up because it has different theta for the same spot?
No, well, yeah, you have to split the integral up because these guys are different.
I think that's what
Yeah.
the problem is. I accidentally put it
In the same integral. Mm-hmm. Since the thetas are slightly different on those two, but not right now. But we might can at the end of class. I have a couple more examples to do. When you finish this, you subtract the whole cardioid minus the small green area, and that's how you get that answer. Okay, we are going to do a couple of AP problems. Before I start, I'm going to pass. That way you don't have to write anything, and you're answering your question on your AP packet that you will have to work with. Okay, so we're going to do 2 AP problems, which is still doing some area, still doing polar functions, but I need to see what they look like in the context of AP problems. Yes. This AP packet is the AP packet for the entire chapter. Just happens that I'm going to work a problem off of it, so you might want to write it down so that you don't have to do it again later. There's not enough room on the AP packet for you to do work this time, so you will need another piece of paper when you do those AP packet problems. I had to make new AP packets so that I haven't worked on the formatting yet to make it where you have room to write in them. Someone who has the AP packet in their hand, find out what number this is so that you can tell it. 5? Okay, cool. So number 5 on your AP packet. It is a calculator allowed problem, as with most of the polar problems. Okay, everyone look at your AP packet. Is anyone missing the back page, numbers 13 through 16? Is anyone missing 13 through 16? We've got a couple of back pages that tore off.
This was missing one.
Here's this missing one.
No, this was a different one.
Okay, throw it away. Because that back page is pretty worthless anyway. And you can just trade your packet out for that. Anyone else missing up the last page? A couple of those were detached. This one is a calculator problem, yes. Most... Oh, well, maybe it was not calculated. I tried to list the correct ones. We'll see if we need it. You want this, you don't get this out of the way since it goes on the back page. That way no one else picks it up with it wrong.
Yeah.
Okay, so find the area bounded by the curve in the x-axis. Step 1. I really think this was a calculator problem. Let me see. I will find out for you. While you're looking, I will find out for sure. Okay, so I think I might have missed part of that record. Is anyone not here today? All right, Patrick. Sorry, I think I paused too long. Area bounded by the curve. This is a calculator problem. We're going to go from 0 to pi, r squared, 1/2, 0 to pi, r squared, theta, d theta. And we get 4 point, what do we get? Meters squared. This is a calculator problem. How do you solve this in your calculator? You could do solve. Now, if you do solve, it will tell you many more answers than necessary. I would probably recommend the graphing screen. What kind of coordinate system do you use to find intersections? Regular coordinates, rectangular, function mode. Put this side in y1, put -2 in y2, and find all of the intersections from 0 to pi. So set your window to 0 to pi so you won't get any extras. What do we get?
2.76.
That's correct. Checking without doing the work. Put one side in y1 and one side in y2, so you have to be in function mode, not rectangular mode. So, and then go to the graph. I would set my window from 0 to pi on my x's because I'm looking for angles from 0 to pi. And find the intersection. You're welcome. And you could do that in the 84 or in the 89, either way, whichever one you prefer. Intersection on the 89, you have to bound it from the left and the right. If y'all figured it out, it's not that much more difficult, but it's different. Okay. For theta between pi over 3 and 2 pi over 3, dr d theta is negative. So it just answers that question for you. Do I need to, are you not getting it?
I'm not.
Okay.
What? So you put it in the functions?
Put this.
Oh, I didn't do times cosine.
Okay. Did you know why you do times cosine?
Mm-hmm.
Yeah, cool. They would not have had to give me this piece of information. They were being kind, because could I have found dr d theta and found that it was negative? So they were being kind in that, not only that, they gave me dr d theta. I am not sure why they did that and why they didn't make you do that. They were, I guess they were feeling they were getting soft on you this year. I'm not sure what they were doing there, but it's okay, we'll take it. They gave us dr d theta, they gave us, they even said it was negative. What does that say about r? If dr d theta is negative, what does that say about r? R is decreasing. What is r? It's the radius, right? So the radius of the graph is decreasing as theta gets bigger from pi over 3 to 2 pi over 3. What does it say about the curve? If r is decreasing. Good. Or you could say the pole. Same thing as the origin. Find the value theta in the interval 0 to pi over 2 that corresponds to the point on the curve in the first quadrant with the greatest distance from the origin. So My opinion, they did part C just to help you do part D. Just to get you thinking about what we're even talking about if we're talking about greatest distance from the origin. We are going from 0 to 2 pi, or pi over 2. That does make a closed interval, so we're doing an absolute maximum is really the question. What is the absolute maximum of r on the interval 0 to pi over 2? Right? Well, what would you do? Definitely plug those into drd theta, but what else? Those are the endpoints. Are you taking the math?
Yeah.
Yep. You just grab one and go for it. I also need to check the derivative and see when it equals 0 and see if there are any other critical points, right? And so the derivative, which you don't even have to find because they were so kind and gave it to you, is 1 plus 2 cosine of 2 theta. Because this is a calculator question, you can just type this in the calculator. However, it does turn out you could solve it by hand. Doesn't matter. You have options. Cosine is, that's a 2 down there, you can't tell. Cosine is negative 1/2 at 2 pi over 3. Am I right? And 4 pi over 3? Probably. Well, we're 0 to pi over 2. Divide both of these by 2. And yes, as Joseph said, now you can probably tell why I waited until this point to make the decision on which ones to eliminate or not eliminate. I'm going to go ahead and divide by that 2 before I make that decision. Does everyone know why I would do that? So we want theta between 0 and pi over 2. So I'm going to eliminate that one. So just pi over 3. And then I'm going to do a true candidates test. You could go ahead and do a sign chart and figure out if pi over 3 is a relative max or a relative min. Or you could just find a value and do a true candidate. It doesn't make any difference. It is a relative max, so then you'd still have to go find the value. So to me, that other step seems to be a wasted step. So I want to find r of 0, r of pi over 3, and r of pi over 2. I have a calculator. So is this hard? No. Plug it in. R of 0 is 0. R of pi over 3. Yeah, pi over 3 plus sine of pi over 2 pi over 3. I don't know what that is. Pi over 3. Go ahead and decimal value that because this one's a decimal too. I need to know which decimal's bigger. Does that make sense? What do I get for pi over... Someone, I think Kit's doing pi over 3. Someone else do pi over 2 for me.
It was 2 squared root of 3 plus 1.
I would just do...
Just 1.
Yeah, pi over 3 plus sine of 2 pi over 3. Make my calculator do all the work. Is which one? Pi over 3. So you said, Joseph. 1.9 what?
9.
And what about pi over 2? No, I'm not... Nobody's lost. So which one... Where is the... And let's go read the question on AP. Always go back. Find the value of theta that corresponds to the point on the curve in the first quadrant with the greatest distance from the origin. So theta is pi over 3. What's my justification? By candidates test. Do I have all the work to back that up? Yes.
Could you justify just saying pi over 3 without doing the math and just saying it said that and see that it was we can see we gradually got closer.
You could use that to eliminate the pi over 2. You'd still need to do a comparison with the 0. And then you'd still have to put that into, I think the justification points would be a little harder to pick up that way, but it could be done, yes. Okay, let's do one more. And this one's got a common interior, so it might be a good one for you to see. What number, 15? That's good, so you don't have to see, this is kind of small up here, that you don't have to see it all. Okay, this is the last problem we will do. What time do we get out of here? 25? Okay, this is the last problem we will do, and then you can ask me questions. Your homework, remember, you'll still have the due dates. What's due tomorrow? 4 and 5, which means 1 through 5 is due tomorrow. The multiple choice is due Friday. Does that sound correct? And then we'll start on AP packet as well. 1, 2, and 3 will be your first AP packet assignment. So you can start working AP 1, 2, 3. I have a due date for that. I'll tell you that tomorrow. 1, 2, and 3 on the AP packet will be your first AP packet assignment. I do, I would have to look it up. But I do have that due date somewhere. I've thought about it. Has today helped with the homeworks? Things we couldn't do, besides maybe 1 or 2 here and there. The graphs of the polar curves r equals 2 and 3 plus 2 cosine theta are shown in the figure above. The curves intersect at 2 pi over 3 and 4 pi over 3. Does it tell you if this is calculator or not? It is calculator. Is that what it says? Okay. It is calculator allowed. As with most. I would argue that they could have made this into a non-calculator with all the information they gave us, but they didn't. You can see they're pretty kind with polar curves on these open response problems. This was 2007. Let R be the region inside the graph of r equals 2, and also inside the graph of 3 plus 2 cosine theta as shown in the figure above. Find the area of R. And there's a couple of ways you can do it. My preference would be to do the addition. Slices all the way to right there. We could just find the area of the circle. Does everyone agree with that? And then I could stop at that intersection and find the area of the, is that a cardioid? Or yeah, whatever it is. Find the area of that other piece. So to do that, I would be integrating the circle. I'm going to do 2 times a half again. You wouldn't have to do it that way, but if I get the top, I get the bottom as well. So I'd double it. From 0, I probably should color code. This is the blue area I'm finding here. From 0 to that first intersection, everyone agree? And if we were unsure, what is the first intersection? 2 pi over 3 of the circle, which is 2 squared d theta. Plus, do the same thing with that red area, which would be 2 times 1/2 the integral, from 2 pi over 3, where to? If I'm doubling, I would stop right there, right? Which would be at pi. If you did want to do the whole area at once, you could, and you wouldn't have to double. You could go from 2 pi over 3 to 4 pi, but then get rid of the 2 if you do that. No, but it doesn't matter. Tomato, tomato. But if you do that, get rid of the 2. To pi of 3 plus 2 cosine theta squared d theta. I do not know what that is. What number on your AP packet is this problem? 15. I could look it up. Y'all can all type that in the calculator, right? Okay, let's look at part B and C and see if we have anything with those that we need answered. A particle moving with a non-zero velocity along the polar graph that has position x of t, y of t at time t with theta equals 0 when t is 0. Particle is moving along the curve so that dr dt equals dr d theta, which is good to note. Find the value of dr dt at theta equals pi over 3. The reason those derivatives are the same, they wouldn't have had to tell you that, but the reason those derivatives are the same is, well, maybe they did have to tell us. Okay, never mind. All right, so dr d theta, which is the derivative of r with respect to theta, the derivative of 3 is 0. And then negative 2 sine theta. And I want the value at pi over 3. I say approximately, we could actually find that. But either way, it is a calculator problem, so they will accept either answer. Sine of pi over 3 is radical 3 over 2, is that right? Interpret your answer in terms of the motion of the particle. What does that mean for the particle? But you can tell this is the second AP problem where they've asked that same type of question. What's happening to the particle? Closer to the origin or the pole. Okay, we may not have time to finish this, but maybe we can set it up. For the particle described in part B, dy dt equals dy d theta. Remember, y is r sine of theta. So I'm going to find dy d theta once I plug that in. And that will say something about the particle getting lower or higher, right? So dy dt is the change in y value, or dy d theta is the change in y value.